when you put a current through a solution of an ionic compound, you can have electrolysis happening in a similar way to as you would with a molten compound, but there are some very subtle differences. And it's all to do with water. Water is in every solution by definition, and you're going to end up with that playing a vital part in it. Now, you may remember from the acids topic that H plus and OH minus can come together to make H2O. Actually, that reaction is reversible, and it's happening all the time. Anytime that you have a water molecule in a solution, some of it will be breaking up into H plus and OH minus. And at any time, some H plus and OH minus ions will collide, come together, and they will be making water again. And this will be happening all the time. Now, the concentration of H plus and OH minus is really, really small. Most of the liquid is H2O, just the molecules of water. But this is happening all the time, and that's really important for electrolysis in solutions. And the reason for that is because if we think about just a cathode at this point, if we put in some metal ions in solution, such as copper, we have copper 2+, which will be attracted to the electrode, the cathode in this case, the negative electrode, but also any H+, which is produced, will be attracted to the electrode as well. By experiment, we find that the copper is in fact what goes to the electrode and is produced or discharged as the product, and actually the H plus doesn't react, it doesn't form anything else. It's just as we'd expect with the molten substance. And the reason for that is that copper is lower down in the reactivity series than hydrogen is. And so that's a good general rule for the cathode. And the lowest thing in the reactivity series is the thing that will be discharged. So with anything less reactive than H+, we're going to end up with that being deposited on the electrode as a layer of copper or anything else. So a solution containing copper, this could be copper chloride, it could be copper sulfate, it doesn't matter, as long as it's got Cu2+ aqueous ions in, copper 2 ions dissolved in water, we're going to end up with the same thing happening. We're going to end up with copper 2+ ions gaining 2 electrons and being reduced to copper atoms. And so it goes with silver as well. Silver is less reactive than hydrogen, and we'll see the same thing. We have Ag+, aqueous, we have silver ions dissolved in water, will gain an electron each, and they will be discharged as a layer of silver. And actually that's quite useful because you can plate things with silver like this, because you can take a solution containing silver ions, you can put something like an iron fork or something like that in as your cathode, you put another electrode in the other end, put a current through it, and you'll end up with your cheap metal being covered in a layer of silver, which makes it look like it's solid silver. It won't be solid silver, but it will look like that, and that's called plating. You can have silver plated cutlery or musical instruments, etc. So if you have a metal which is more reactive than hydrogen, it's the less reactive substance which is going to be discharged. So in this case, if we have zinc ions, they are going to stay in the solution, and it's actually the hydrogen which is going to come out. Hydrogen being a gas, you're going to see bubbles of hydrogen forming on the cathode, and if you were to collect that gas by putting an upturned test tube over the top of the cathode, you could do the squeaky pop on it and test on it, put a lit splint in the top, listen for the squeaky pop, and you could prove that it was hydrogen. And the OH minus just drifts off into the solution. Metals more reactive than hydrogen will therefore discharge hydrogen on the electrode, and you'll see that as bubbles, and you'll see that as bubbles of H2 gas. So the equation that we'd be looking at for any solution containing any metal which is more reactive than hydrogen would be the same. It would be the H+, the dissolved H+, turning into gaseous H2. So the equation for that is 2H+ plus 2E minus goes to H2. When we look at the anode, we have some slightly different rules. With this, it's very complicated. There's the concentration of what's there is important, as is something called the electrochemical series. But for GCSE, generally the rules balance out so that if we have a halogen there, such as chlorine or anything else in group 7, we would expect that to go to the anode, and that would form, again, what you'd expect for a molten compound containing a chloride or something like that. So any halogen, any halide ion that's in the solution is going to produce that halogen. So chloride ions will produce Cl2, bromide ions will produce Br2, and we'll end up with these equations here for that, just as you'd expect in a molten electrolysis. For everything else at GCSE level, with the concentrations we use, and we can show this by experiment in the lab, we will end up with actually the OH- ions being the ones which are going to go to the anode and react to form a product. And that product is going to be oxygen. Now, it's not quite as simple as it just forming oxygen, because you've got OH-, there's some hydrogen there as well, and so actually what we form is oxygen and water, but the water just goes back into the solution, and so we say the product itself is oxygen. So for any other anions, sulfate, nitrate, hydroxides even, anything like that, you're going to get the OH- going to the electrode to produce water as a liquid and oxygen as a gas, and we say that the oxygen is the product. And the equation for that, we have 4 OH- ions required, and we produce 2 H2O molecules, and we end up with O2 as the gas which is given off, and 4 electrons are lost. So because it's loss of electrons, again, it's oxidation. So just a summary. Basically the rules are, at the anode, if you've got a halide, it's going to produce the halogen. If you have anything else, it's going to produce oxygen and water. And at the cathode, whatever it is in the reactivity series that is least reactive out of your options, that's what's going to be discharged.